Hi students, this is Mr. Yang. Today we are going to talk about 6.5, which is the last lesson in this unit about triangles, which is called coordinate ratio with line segments. In this lesson, we're going to use the similar triangle and proportionality to kind of help us to find some line segments, find some points in the line segment. Prior knowledge. So distance. Even though eventually we're not going to use distance to exactly help us to find the more complicated questions, but it's a good review right here. So just to remind you about the distance formula, distance is x2 minus x1 then squared plus y2 minus y1 and then squared. That's how we calculate distance. If you remember, if you have 2 points in a coordinate system, basically you can form a right triangle, and horizontally that's your x2 minus x1, and vertically that is your y2 minus y1. And that's why it basically is a squared plus b squared, then we take a square root to find the hypotenuse. So let's deal with these two questions. x2 minus x1 is going to be 3 minus negative 1 squared. Then it's negative 6 minus 2 squared. So first part, 3 minus negative 1 becomes a 4. So we're going to have 4 squared. Negative 6 minus 2 is negative 8. But when you square it, the negative kind is gone, so it's 8 squared. That's going to be added together to be square root of 80, which simplifies to be 4 square root of 5. That is question A. Question B, same thing. x2 is negative 1, x1 is negative 3, so minus negative 3, then squared. y2 is negative 3, minus y1 is negative 2, so plus 2 in that case. We're going to end up with negative 1 plus 2 is a 2, plus 3 is a 2 squared. Negative 3 plus 2 is a negative 1 squared, but again, when you square it, the negative sign is gone, so that is going to be simplified to be square root of 5. So that's prior knowledge. We can choose to use distance to solve these questions, but the faster way wouldn't actually involve anything about distance. So let's actually move on to the next part. Triangle proportionality theorem. Well, this is something we have learned in 6.3a. If you have forgotten about it, you can go back and refer to the 6.3a video. Triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So you have two parallel lines which cuts each side into two sections, so right here and right here, and we can use these two sections to actually form a ratio. So RT over TQ is the same as RU over US. So the same proportion on the top side and the same proportion on the bottom side. Another way to write it again, you can either choose to write it in the same side, which is like this, or you can choose to write the top over bottom. So RT over RU is the same as TQ over US. Okay, there we go. Now let's get to the two examples. These are just two quick examples to kind of review about proportionality theorem. Let's say that is your x, which is RQ. So if you stay on the same side, so x over 9 is the same as 4 over 6. That's if you stay on the same side on the left and then stay on the same side on the right side. Or you can choose to do left over right is the same as left over right, which would be x over 9 is the same as, x over 4 is the same as 9 over 6. You can multiply both sides by a 9 and by a 6. Then after finish solving, x is going to be 6. That's example 1. Example 2, say that's your x. Two different ways to set it up. I can use the left side, so x over 3, and then the right side, which is 12 over 4. Or you can do left over right, so x over 12 is the same as 3 over 4. And in that case, I can choose to multiply both sides just by a 12. Or in this, I'm going to need to multiply both sides by a 3 to get rid of the 3, then multiply both sides by a 4 to get rid of the 4s. And that's going to give you x equals 9. That is example 2. These are quick reviews of the proportionality theorem. Again, if you forgot, go back and refer to 6.3a. Now let's move on to today's lesson. Line segments, and we're trying to find a point in that line segment. Example 3, find C between A, which is negative 7, 2, negative 7, 2, right here, that's my A, and B, which is 3, 2, 3, 2, and is asking to find a point C in between them, so that is my B. It's asking to find a point C in between so that AC over BC is 4, or in other words, 4 over 1, since this is the ratio. I'm going to randomly put a point C down on AB, so that as long as it kind of looks like AC over BC is 4 over 1. So let's say around here, that kind of looks like a 4 over 1, which is great. So that is my potential point C. Doesn't have to be precise. I'm just putting down a point on there so that you can kind of have a visual. So AC over BC, it is 4 over 1. However, I don't know where C is. So just knowing AC and BC, I still don't know their length, which wouldn't help me do anything. Which is why I'm going to have to depend on AB, because just by drawing, I actually know exactly how long AB is. So I'm going to make some changes. Here's the change. In order for me to get to AB, something you do need to understand is AC and BC together makes up AB. So I'm going to need to change one of them to become AB. So if I need the bottom BC to become AB, I'm going to add an extra AC. So it's almost like I'm adding the number on the top. So on the right side, this 1, I'm going to add a 4, because in comparison to BC, AC is actually a 4. Okay, now I'm going to keep going. AC plus BC on the bottom is actually AB, and that is 4 over 5. The reason I have to use AB is because now if you look at it, A is -7, 2, B is 3, 2. I know exactly how long AB is. It is 10 units apart from each other. So I can now replace AB with a 10. So you have this equation. Let me rewrite it. AC over 10 is 4 over 5. There we go. Now I can actually easily solve AC. Multiply both sides by a 10. AC equals 8. Which means C is 8 away from A. That's how we understand that AC equals 10. The length from A to C is 8. And because A is currently -7, 2, and C is to the right of it, so I need to add the x coordinate. That's going to give me C as 1, 2. So that is one way to deal with it. But in this question, I also have the other part. It doesn't have to be AC over AB. What if I choose, let's say I start with AC over BC, which is 4 over 1. What if I actually want to keep the BC? Well, then that means I can actually change the top to try to become AB. So I'm going to add an extra on the top. Because BC is basically 1, so I'm actually adding a 1. So that's going to give me 5 over 1. And in this case, it is AB over BC. Well, in that case, I still know my AB is 10, so I can rewrite it as 10 over BC, which is 5 over 1. To solve it, I'm going to multiply both sides by BC. So this is gone. So 10 equals 5 BC. That means BC is 2, which means C is 2 away from B. But C is to the left of B. So in order to find C, I need to use the B coordinate, which is 3, 2. But I need to actually subtract 2 since C is to the left of B. But the Y coordinate does not change. And that is still going to give you C as 1, 2. So you have two different ways to deal with it. You can either use the AC portion or use the BC portion to compare it with AB. So here you may notice if I'm deciding to keep AC, I'm not going to change the AC. I'm going to change the BC into AB. But if I've decided to keep the BC, I'm going to change the AC to become AB. So that is example 3. Let's do another one. Example 4. A is 3, -2, and B is 3, 5. And AC over BC is 2 over 5. So A somewhere C, let's say that's my C, is actually 2 over 5. So let's actually do both methods. First method, let's say I want to keep AC. So originally I have AC over BC, that is 2 over 5. But if I choose to keep my AC, well, that means I need to change the bottom to become AB. So I'm going to add AC, which on the right side is adding the 2. I will get AC over AB, that is 2 over 7. But I already know how long AB is. It's -2 to 5, so the whole AB length is actually a 7. And I can multiply both sides by a 7. AC would have to be 2, which means C is 2 away from A. And since C is above A, that means I just need to add the 2 onto the y coordinate. So C is going to be 3, then -2, which is the coordinate from A, then add the change, which is 2. That's how I got that part. That's going to give you C as 3, 0. There we go. Now let's actually use the other method. Let's say now I actually want to keep BC. So let me copy it down. AC over BC is 2 over 5. But this time I actually want to keep my BC, which means I need to add an extra BC on the top so that it can become AB. So on the right side, I need to write the same number on the bottom. In that case, I got AB on the top over BC. That is 7 over 5. And same thing, I still already know AB is 7. So I'm going to multiply both sides by BC to get it out. And then I'm going to multiply both sides by 5. So I have 7 BC equals 35, and that means BC is 5. But that means C is 5 below B, so now I actually need to use the point B, which is the y coordinate, so 3 stays there, but it's going to be 5 minus 5. That is still going to give you 3, 0. That is example 4. Moving on, example 5. A is 3, -6, and B is 3, 5. There's my A, there's my B, and AC over BC is 2 over 5. So I'm going to kind of roughly guess maybe somewhere around there is my C. I don't exactly know. Not precise at all. It's just a guess, but it's a 2 over 5. So you can pause here and try to set it up. Try both ways by yourself, and then you can come back and check. So the first way, let's say I have AC over BC, that is 2 over 5. If I have decided I'm going to keep my AC, then I need to add AC on the bottom, or add a 2 on the bottom. So I have AC over AB equals 2 over 7. The whole thing from A to B is actually 11 long. So I can replace that with 11, multiply both sides by 11. So AC has to be 22 over 7. Remember, this means C is 22 over 7 above my A. So it's only the y coordinate that is changing. So C would have to be, the x coordinate stay the same, which is 3. Then it's going to be a -6 plus 22 over 7. That is the first way if I want to keep AC. Now the second way, let's say we still have AC over BC was 2 over 5. But let's say I actually want to keep my BC in this case, my BC. So I'm going to need to keep it. I'm going to need to add a BC on the top or add a 5 on the top. That's going to give me AB over BC equals 7 over 5. Now it's time to solve it because I already know AB is 11. Time both sides by 5 and time both sides by BC. So BC cancels on the left, 5 cancels on the right. At 55 equals 7 BC, so BC would have to be 55 over 7. And in this case, that means C is 55 over 7 below B. So in order to find my point C, I need to keep the x coordinate, but the y coordinate, since it's below, I need to subtract 55 over 7. No matter what, both of them will give you the same answer for C, which is 3, -20 over 7. That is example 5. Moving on, example 6. A is -2, 1, -2, -1, and B is 4, 7. Connect them. AC over BC is 2 over 3. Well, probably somewhere like around here is my C. It's 2, 3. Well, here's the issue. It's not on the grid anymore. And if you actually want to use the length of AB, which is going to be like a radical, it's going to be very hard for you to find any ratio with the radicals or for exact value. So that's why in this case, we can't exactly deal with it directly. So we're going to have to depend on the last few examples we have learned. We are going to need to somehow drop all of these information onto the grid lines, which is why we are going to create a triangle. And I'm going to call this point D. The reason I create a triangle is because now I can exactly know AD, the length of AD, and the length of BD. So we're going to do a bit extra, and this is where we're going to need to use our proportionality theorem. I'm going to drop down from C to get a point on AD. So where did I go? Okay, let's see, AD. So like I said, I'm going to drop a line down from C to AD. Let's call that point E. The reason I do this is because in the previous lessons when we learned about proportionality theorem, every time we're going to need to have parallel lines. And these two, CE and BD, are actually parallel because they're kind of both grid lines. And with that in mind, that tells me proportionality theorem AC over CB, which is 2 over 3, is the same as AE over ED, which is 2 over 3 as well. And something else that is important, E, you see, I dropped down the line from C to get E. So they actually share the same x coordinate. So I'm going to use point E to help me find the x coordinate for C. So AE over ED is 2 over 3. That's something I already know because of the proportionality theorem. And then, same thing, now this just become one of those previous examples we dealt with. We're trying to find the x coordinate for E. So I have to use AD since I don't exactly know where E is. So I can choose to keep AE, but I'm going to change that ED to become AD, which means the ratio is going to become now 2 over 5. Since in order for ED to become AD, I need to add the extra part, which is on the right side, adding the 2 onto the 3. So AE over AD is actually going to be 2/5. And from the question, I know exactly what AD is. AD is 6 long, which means AE, multiply both sides by a 6, would have to be 12 over 5. Remember, I don't have to find the exact coordinate for E altogether. I just need the x coordinate for E, because the x coordinate for E is the same as the x coordinate for C. And E is to the right of A, so I'm going to need to use the x coordinate for A, which is -2, then it's to the right of it, so I'm going to add a 12 over 5. That is going to give you 2 over 5. That is to find the x coordinate. Now I'm going to go a bit further. I'm going to find the y coordinate. So in that case, I need to actually draw a horizontal line from C so that I can use it to find the y coordinate. I'm going to call this F. And same thing, the CF is actually parallel to AD, so I can have proportionality theorem again. BC over CA is the same as BF over FD, which is 3 over 2. So BF over FD is 3 over 2. Something else, F has the exact same y coordinate as C, so I'm going to use that to find the y coordinate for C. So BF over FD, it is 3 over 2. The same thing, I can't just use point F, I have to depend on BD, so I'm going to keep the BF and then change the FD to BD, which means I'm adding an extra piece on the bottom of the fraction, so on the right side I have to do the same. So keep the 3 on the top, the bottom need to add the extra piece, so 2 plus 3 is a 5. And then I do already know what BD is. BD in total, the actual length from B to D is 8. Now I can multiply both sides by 8. BF is 24 over 5. And the reason I use point F is because it has the same y coordinate as C, which is below point B. So I'm going to use the y coordinate for point B, which is 7. Since it's below, I'm going to subtract 24 over 5. That is going to simplify to be 11 over 5. So I have the y coordinate for C and the x coordinate for C, which means my C has to be 2/5, 11/5. That is example 6. Moving on. The last example, example 7. So let's put the points down. A is negative 2, 1. B is 1, 5. There we go. And AC over BC is 2 over 3, so it's probably somewhere around here. But here's the thing. If you look at the whole graph, well, the whole triangle is not big. So for this example, I'm trying to show you if the shape is not big on your grid system, you can kind of move it out of the grid and make it a lot bigger so it's visually clearer. So I'm going to redraw it. Let's say we have a and my B, and my C on the top in the middle, which is 2 over 3. But here's the information you actually need to include. You need to know D, and you actually need to know how long is AD, which in this case is actually a length of 3. You also need to know how long is BD, which is a 4. Then you can start adding extra things to help you find the coordinates. First, let's drop down from C, which is going to give us a point E, to find the x coordinate. So AC over CB is the same as AE over ED, which is 2 over 3. So let's start setting it up. AE over ED is 2 over 3, and I'm keeping the top, so I'm changing the bottom. So it's going to be AE over AD, that is 2 over 5. Now, I do already know what AD is. The length of AD, I have already taken it out of the graph. AD is actually 3. So multiply both sides by 3. My AE is going to be 6 over 5. Then I'm going to use that to find the coordinate x coordinate for C. So because the x coordinate for E is the same as the x coordinate for C, which is to the right of A, so I'm going to use the x coordinate for A, which is negative 2, add the 6/5. That is going to give you negative 4/5. Next, I'm going to use point F now to find the y coordinate for C. And BC over CA is the same as BF over FD, so it's going to be 3, 2. So in case you haven't noticed, when you set up the x and the y, it's kind of backwards, just because the proportion changed, the order changed. So BF over FD is 3 over 2. So I'm keeping the BF, I'm changing the FD into the whole thing, which is BD. So BF over BD, since I changed the bottom, I need to add the extra part to the bottom, so 3 on the top, 5 on the bottom. Now I already know the length of BD, which is 4. So I'm going to multiply both sides by the 4 to solve the equation. BF is 12 over 5. But that means F is 12 over 5 below B. So I have to use the y coordinate for B to find the y coordinate for F, which is the same as the y coordinate for C. That is going to be 5 minus 12 over 5, which simplifies to be 13 over 5. So the coordinate for C would be negative 4/5, comma 13 over 5. So this example kind of let you see that if the graph is too small, well, make it bigger. You can make the triangle bigger to see everything clearer. That is example 7. That is everything for 6.5. Thank you.